Welcome back to our geometry series. We are up to section 2.5 where we will be discussing polygons. A polygon consists of three or more coplanar segments called sides. The sides only intersect at endpoints, each called a vertex. Each vertex belongs to only two sides. Polygons are named by writing their consecutive vertices in order, such as W, X, Y, Z in this case. The word polygon is from two ancient Greek words, poly, meaning many, and gon, meaning angles. Here are four shapes that we've drawn. Which of these are polygons? The first and third shapes are polygons, but the second and fourth are not. In the second shape, we have two vertices that have more than two sides joining at that point. In the fourth example, we have a side that only touches one vertex. That's why these two are not polygons. A polygon separates a plane into three sets: the polygon itself, the points in the interior, and the points in the exterior. So here we have two polygons, A, B, C, D, E, and F, G, H, I, J. The polygon on the left is what we call convex. There are no points on the interior of the polygon. The polygon on the right is concave. Point J is on the interior. The segments FJ and JI, if we were to extend them, you can see that they intersect and go inside of the polygon. That's what makes this a concave polygon. A diagonal of a polygon is a segment that joins two non-consecutive vertices. For example, BE is a diagonal of this polygon. Let's jump over the whiteboard and look at some polygon parts. Alright, we're going to draw a little shape here. 1, 2, 3, 4, 5, and 6. And we're going to call this A, B, C, D, E, and I'll put the F here. So what could we call this polygon? What name could we give it? Well, we'd have to call it by its points in clockwise order. So typically we would start with the earliest alphabet letters, so A, B, C, D, E, F, but you could also name this D, E, F, A, B, C. Next, is this concave or convex? Well, looking at the points, if we were to pretend that we'd extend everything out like this, do these dotted lines go on the inside of the polygon? So let's just extend all of the segments and see what happens. So as you can see, none of the dotted lines go onto the interior of the polygon. So this makes it a convex polygon. So let's look at one of the vertices. Let's look at D. Let's find a diagonal from D. Let's just draw this one here. BD is a diagonal of this polygon. How many diagonals are there in total in this polygon? Well, let's do all of them from D. So DB, that's 1, 2, 3, but there are more diagonals than that. So 1, 2, 3, let's go over here. 4, 5, 6, 7, 8, 9. There's 9 diagonals. So each point has 3 diagonals. It has 3 points you can reach that aren't part of the side segment. So from F to E, that's a segment, and A to F, that's a segment. Those two are sides, but the 3 other points of the polygon give us the diagonals from point F. A polygon is named by the number of its sides. So if a polygon has 3 sides, it's a triangle. 4 sides, equilateral, and so on. Pentagon, hexagon, heptagon, octagon. There are unique words for all of these sides. However, when you get to larger numbers, say 27, usually it will just be referred to as a 27gon. A polygon with n number of sides is an n-gon. A polygon can be equilateral and or equiangular. So here are 4 polygons that have been drawn. The first one is equilateral. All of its sides are the same length. The second one is equiangular. All 4 angles are the same. In this case, they're all right angles. For the third polygon, it is equilateral and equiangular. And the fourth one is a shape that is neither equilateral or equiangular. A polygon is regular if and only if it is both equilateral and equiangular. So a square is a regular quadrilateral. The perimeter of a polygon is the sum of the lengths of its sides. Here's an irregular polygon, and the sides that we have already measured. So the perimeter is 5 plus 3 plus 10 plus 3 plus 8. So the perimeter is 29. Let's jump back to the whiteboard and do some examples of polygons, types, and their perimeters. So let's draw some polygons here. We're going to do this, this, and this, and this. And I'm going to draw the lengths of the sides. 5, 7, 6, and 3. So first, we're going to call out the type based on its sides. So there are 4 sides, so this is a quadrilateral. Now the 4 sides are different lengths, so we know that it is not equilateral, and the angles look very different, so we know it's not equiangular. So this is just irregular. But the perimeter, P, is going to be 3 plus 6 plus 5 plus 7. That's 10 plus that equals 21. Next, we're going to draw a an octagon, 8 sides. And we're going to put the length of each side next to each segment. Even though it's not drawn super well, the numbers say that they're all the same length even though they don't look like it. So because the sides are all the same length, it is equilateral. And then since there are 8 sides and they're all 4, we can do some quick math. The perimeter is 32. This is actually a regular octagon. If I had drawn it a little better, we could see that all of the angles are the same and all of the segments are the same length. So that makes it a regular octagon with a perimeter of 32. And that's it for today. Stick around if you'd like to see more examples. Okay, we're going to do something similar to our first example. And we're just going to label this, let's see, F, G, H, I, J, and K. So first of all, it says concave or convex. Imagine, again, we're going to pretend that we could extend all of these lines. If we did that with all of them, you'd see that none of the dotted lines go into the interior of the polygon. So this makes it convex. So a quick example of a concave polygon would be something like this. Right? If we were to extend this segment, we'd see that now the segment extends inside the polygon, and so does this one. So this right here would make this concave. Well, let's get that out of here. So we're going to name this polygon. I'm going to put it way down here, and I'm just going to name it F, G, H, I, J, K. But we could rename it as K, F, G, H, I, J. It's the same points in the same order, we're just starting at a different point in the polygon. Next, let's draw and find all of the diagonals from F. So here's F. So FG is a side. It's not a diagonal, but it connects from F to the other points of the polygon, not including the sides. So FG is not a diagonal. That's a side. FK is not a diagonal. It's also a side, but this is a diagonal, and this is a diagonal, and so is this. So there are 3. It would be FH, FI, and FJ. Next, I'm going to put the lengths of these segments on here. That's 5, that's 4, that's 4, and that's 5. It's getting a little busy here. Let's just put them in circles so we can see them a little clearer. These are the lengths of the segments, or the sides. So what is the perimeter? So all we need to do is add up the sides. Let's start here. It's 5 plus 3 plus 3, 5, 3, 3, 5, 4, 4, plus 5 plus 4 plus 4. So let's do some easy math here. There's a 10 and a 7 and a 7, so that's 24. I'm going to clean this off and we'll do one final bonus problem. So we've got a quadrilateral. So we're going to draw something with 4 sides. We don't know if it's regular, equal angular, any of that kind of stuff. So all we know are the sides are 3x, 2x, again, not really drawn to scale here, 4x minus 5, and x plus 10. The other thing we know is that the perimeter is equal to 45. So what is the length of each side? Well, we have the perimeter, and we have 4 values for its sides. So when we add all of these up, we should get 45. So let's draw this, maybe we can squeeze it in here. 3x plus 2x plus x plus 10. Oh boy. Plus 4x minus 5. Minus 5. Minus 5. Did not fit that in there very well. So now we can combine like terms. 3x plus 2x plus x plus 4x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10x plus 10 minus 5. So that's plus 5 equals the perimeter, 45. 10x minus 5. Back to our geometry days. We're going to subtract 5 from both sides. We get 10x equals 40, or x equals 4. But we're not trying to solve x. We're trying to figure out what the lengths of the sides are. So this is 3 times x. So 3 times 4. This one is 12. This is 2x, so that's 8. This is 4x minus 5, so 16 minus 5, that's 9. And x plus 10, so this is 14. As you can see, I did not really draw this right, but we used that to find out what the actual length of this quadrilateral is. And now that we see that the lengths are in fact different, and we could probably guess that it's not equilateral. We know it's not equilateral because the lengths are different, and we could probably assume that it's not equal angular, so it's irregular. And that's it for today. We'll see you next time.